Okay, so you're ready to take that deep dive into Scikit-Learn. Huh.
Sounds like it.
That's awesome.
Yeah,
Well, that tells me you are really ready to get your hands dirty with machine learning and Python,
absolutely.
and we are too.
Yeah.
We've got some great excerpts here from Scikit-Learn, from machine learning,
hmm
core concepts and applications, to really kind of give us that inside scoop on this powerful library.
It's such a good library.
Yeah.
For anybody who wants to get started, and even people who've been using it a while,
Yeah.
I feel like you can always learn something new about Scikit-Learn.
Oh, absolutely.
Like every time I go back to it, I'm like, oh, wow, there's a whole section on this I never even looked at.
Yeah, exactly. And we're going to do that together.
Yeah,
We're going to explore the difference between supervised and unsupervised learning.
love it.
We're going to uncover the secrets of feature engineering.
It's a secret.
Yeah, it's
Yeah.
a secret. And then we're going to learn how to even determine if your model is truly up to snuff.
Like, how do you know? How do you know if it's good or not?
Exactly.
Yeah.
Yeah, is it doing what it's supposed to be doing?
Yeah.
And you know what I think is really cool about Scikit-Learn is that it's not just giving you these tools.
Right.
It's actually empowering you to make informed decisions
Absolutely.
with this library.
Yeah.
It's like you're not just blindly applying algorithms.
You're understanding.
You're understanding
Yeah.
the strengths, the weaknesses,
Yeah.
and really when to use each one.
Exactly.
So it's not just like, here's a hammer, go hit some nails. It's like, here's all these tools. Which one is best for this job?
And we're going to teach you which ones
Yes.
are rich jobs.
Okay. So let's kind of map out our journey a little bit.
Okay.
We're going to start with the foundation here.
Foundation.
Okay.
Okay.
Supervised and unsupervised learning.
Love it.
So supervised learning, you know, I think a lot of people listening are already familiar with this, but
Yeah.
you've got labeled data, and your model is basically learning from that data to predict outcomes.
Totally.
Right.
Think of it like this.
Yeah.
Think of it like learning to bake with a recipe.
Oh, I like that. Okay.
So the ingredients are your data.
Okay.
The instructions are the algorithm.
Yeah.
And the delicious cake is your prediction.
Okay.
So you're guiding the model, you're teaching it the relationships between ingredients and the final product.
I see. So it's like I'm showing it all the steps along the way,
Exactly.
and it's learning from that as we go.
You got it.
Okay.
That's supervised learning.
Okay. So then unsupervised learning would be more like being
Oh.
handed a basket of mystery ingredients.
Yes.
And you have to figure out what to make without a recipe.
You're exploring the data,
Right.
looking for natural groupings or patterns.
Okay.
So like, say you're a baker trying to invent a new pastry.
Okay.
You might experiment with different combinations of ingredients, observing the textures and flavors that emerge.
Right.
Unsupervised learning helps you find those hidden relationships in your data.
Oh, that's really cool.
Yeah.
So like it's almost like I'm not even giving it any instructions. I'm just like,
You're just giving it data.
here's the data.
Figure it out.
What can you do with this?
Exactly.
Interesting.
Oh, okay.
So with all these algorithms available in Scikit-Learn,
Yeah, there's a lot.
there are a lot. How do you even choose
Well,
the right one for a specific problem?
it depends on the task and the type of data you have.
Okay.
So for instance, if you're tackling a supervised learning problem with continuous data
Continuous data being,
that can take on any value within a range,
okay.
like height or temperature,
Okay.
and you're trying to predict a numerical value,
Okay.
linear regression might be a good starting point.
Okay. I've heard of linear regression.
Yeah.
It's pretty popular.
Yeah, it's a classic.
Yeah.
But if you're dealing with categorical data,
So that's data that falls into
distinct categories,
like categories like
maybe color
colors or like
or like types of fruit.
types of fruit. Okay.
Yeah, you might opt for something like logistic regression.
Logistic regression. Okay.
Yeah,
And our source actually mentions linear regression,
it does.
and it even provides a code snippet for us.
A little code snippet.
Yeah. Could you walk me through that?
Absolutely. So this snippet shows how to create and train a linear regression model.
Okay.
It starts by importing the necessary modules from Scikit-Learn.
Okay.
Then you create a linear regression object
Mhm.
and fit it to your training data.
Okay.
This fitting process is where the model learns the relationship between your input features and the target variable.
Okay.
Finally, you can use the trained model to make predictions on new data.
Oh, cool. So it's like
Okay.
we're teaching it, and then it's able to use what we taught it on new data.
Exactly. It's applying its knowledge
Gotcha.
to new situations.
Okay. So that's supervised learning. What about unsupervised techniques?
Yeah.
The source mentions K means clustering.
K means clustering.
Can you tell me about that?
It's great for grouping data points based on their similarities.
Okay.
Imagine plotting customer data on a graph where each point represents a customer.
Right.
K-means helps you identify clusters of customers who are close to each other based on their characteristics.
I see.
This is useful for things like targeted marketing.
Oh, that makes sense.
Yeah,
But when wouldn't I want to use k-means?
that's a good question.
Yeah.
So K-means assumes your clusters are spherical
Okay.
and roughly the same size.
So they're kind of like neat little...
Neat. Yeah.
Okay.
If your data doesn't fit those assumptions,
Yeah.
you might end up with misleading clusters.
Oh, I see.
It's like trying to fit square pegs into round holes.
Okay.
You need to know your data and choose the right tool for the job.
Know your data. That's a good point.
Yeah.
Okay.
Very important.
So speaking of prepping data,
Yes.
let's dig into feature engineering.
Love it.
I loved how our source called it the secret sauce
Ah, the secret sauce.
of machine learning.
I like that.
Yeah, it sounds more like cooking than coding.
It kind of is.
Right.
So feature engineering is all about transforming raw data into a format that your model can understand and learn from.
Hmm?
It's like preparing ingredients before cooking.
Right.
You wouldn't throw a whole onion into a soup, right?
No, not usually.
You might chop it, dice it, or caramelize it,
Right.
depending on the flavor you want.
So how does Scikit-Learn help with this data prepping?
Scikit-Learn provides tools like Standard Scaler,
Standard scaler.
which scales features to have 0, mean, and unit variance.
Okay.
This ensures that all your features are on a similar scale,
Right.
preventing features with larger values from dominating the learning process.
Okay.
It's like making sure all your ingredients are measured in the same units before you start mixing.
That makes a lot of sense.
Yeah.
Okay, so you've trained your model.
Okay, trained it.
You've prepped your data.
Practice.
Now, how do you know if it's any good?
That's the question.
Yeah.
That's where model evaluation comes in.
Right.
We need to see how well our model generalizes to new unseen data.
Yep.
One technique is cross-validation.
That's validation. All
So
right.
we split our data into subsets,
Uh-huh.
train on some,
Okay.
and test on others.
I see.
This gives us a more robust estimate of performance than simply testing on the same data we trained on.
Okay, that makes sense.
Yeah.
So then how do we measure that performance?
There are metrics like accuracy,
Okay.
precision, and recall,
Mm-hmm.
each providing different insights.
Oh.
For example, accuracy tells you the overall percentage of correct predictions.
Got it.
Our source even has a code snippet demonstrating how to calculate accuracy using Scikit-Learn's accuracy score function.
That's awesome.
I know, it's so cool.
It's like you're not just talking about it. They're like, here's how you do it.
Exactly.
I love that.
It's practical.
Yes, it's super practical.
Yeah.
What are some real-world applications
Oh, there's so many.
of Scikit-Learn?
Yeah, so for supervised learning, it's predicting customer churn, identifying fraudulent transactions,
Makes sense.
personalizing recommendations.
Okay.
In unsupervised learning, it's clustering documents for information retrieval
Okay.
and detecting anomalies in network traffic.
So it's really used everywhere.
Everywhere.
It's incredible.
No, it's like this secret weapon
Yeah.
of the modern world.
So Scikit-Learn really is a powerful and versatile tool.
It is.
Like you said, it's this secret weapon
Yeah.
that's being used all over the place.
Yeah, and remember, Scikit-Learn is just one step.
Right.
The field is constantly evolving, so keep experimenting, keep learning, and who knows?
Mm-hmm.
You might develop the next groundbreaking machine learning application.
That's so true.
Yeah,
So much to explore. We've only just scratched the surface here.
just a little bit.
But you've got the tools and the knowledge
You do.
to continue your machine learning journey.
Absolutely.
Keep diving deep.
Keep diving deep.
That's it for this deep dive into Scikit-Learn.
See ya.
Thanks for listening.
Yeah.